To work in the CYU problem on row 2, what I want to do is I want to simplify the picture which they give us of this wheel cover that has a diameter of 12 inches and has wires that are all equal length. So what I did is I highlighted 4 wires in there that are equal length, and those 4 wires create a square. And that is a square that I'm going to pull out and highlight in the diagram down below. Now we know that this circle has a diameter of 12, and if I draw a diameter, it has to go through the center, and I notice that that goes through the edges of the square. So I'm going to pull that in, and I'm going to look at this diagram down below it. This is the same figure, only now I've got a diameter of 12. If that's a diameter of 12, then it forces each radius to be equal to 6, because there are 2 radii in one diameter. So now I have a picture where both of those are 6. If I were to draw in the second diameter, or the second diagonal of the square, however you want to look at it, we get a picture or diagram that looks like this. Now back in Unit 3, we learned about the diagonals of a square. If you have the diagonals of a square, there are 2 things. They are perpendicular bisectors of each other. Well, the important part that I want to draw on here is when 2 diagonals of a square cross or intersect, they form a right angle. Well, that's pretty important because that gives us a right triangle. And because this other one was a diameter, then each of these has to be 6 and 6 for the radius. So what we're going to end up with is a right triangle with 2 legs of the right triangle being equal to 6. So what is the length of each of the wire cords? What they're really asking us to do is to find the length of this cord that's in green. Well, then that means we can use the Pythagorean theorem to help find that. I'm going to call that C, since that's the chord. It's also the hypotenuse of my right triangle. So C squared should equal 6 squared plus another 6 squared, or C squared should equal 36 plus 36, which is 72, or that means C is equal to the square root of 72. And you can take your calculator and get an approximation. I believe it's somewhere close to 8.5. So that chord length is 8.5. So that is what I want to do with question A. Okay, so now with question B, it says, more wire cords can be added to the design, but none can be closer than 3 inches to the center of the wheel cover. So I want to change and adapt my picture a little bit to this. What they're telling me is, not that the center or that the diameter changes, but we want to make sure that when we draw a cord, none of these cords can be any farther away or any closer to the center than 3 inches. So I'm going to put that in there. I'm going to say this represents a distance of 3 inches. No cord can get closer than that. If I try any other cords, for instance, if I just do this, if I move away farther than 3 inches, then the cords would be shorter. So that's why they're saying what is the longest possible wire cord that can be added to this design if we maintain the fact that it can't be any closer than 3 inches closer to the center. So I'm going to bring my diagonal back in here now. The reason I want my diagonal in here because that way I can help identify the radius again. And our radius has a length of 6. Our cord that we're going to be using, I'm going to use that in green. This cord has to stay 3 inches away. But when I do a distance, when they say that the distance is 3 inches away from the center, that is the perpendicular distance. You always measure distance from a point here to a line here the shortest possible way. And the shortest possible distance between a point and a line is a perpendicular distance, which again gets us back to a right triangle. So I'm going to connect the center to the shortest path to the cord, which is going to be perpendicular. But remember, if we have a line that is going through the center and perpendicular, then this point has to be the midpoint. So that's the midpoint of this green cord. That's going to allow us to help us figure out what the green length is, because we can use our Pythagorean theorem to find just this side of it and then double it to find the other side. So if we apply our Pythagorean theorem this time, C squared equals A squared plus B squared. This time I'm going to call this B, since that's not the hypotenuse. So the hypotenuse is 6. We square it. We add, or it equals our 3 squared plus our B squared. So it's 36 is equal to 9 plus B squared, which means 36 minus 9 is 27 equals B squared. And that means B is the square root of 27. Again, if you take your calculator and you punch that in, B is approximately, I believe it's a 5.2. So if that's 5.2, then the entire length of it has to be double that value. So we take it times 2, and it's going to be 10.4. 10.4 is the length of the longest cord possible if it has to stay and maintain a distance of 3 inches away. Okay, the follow-up question then in part 2 is, what is the measure of the central angle of the longest of these chords? Okay, sorry for the interruption. We're going to get to solving for that angle here in a second. What is the measure of the central angle of one of these longest chords? So what I'm going to do is I'm going to bring in the diameter. Okay, sorry for the interruption again. I'm going to bring in the other diagonal, or the other diameter. This is still a 6. This is still a 3. Our requirements is that it can't be any closer than 3 inches to our center. We want to find this central angle. That's what they're asking us for. What is the measure of the central angle of one of these longest wire chords that's going to cut off this intercepted arc for this chord? So we want to find that angle. What we want to do is be able to first break it down into the smaller right triangle that we had here. So if I want to find this angle in the right triangle, that's fine, because I'm going to use that to help us find the green one by doubling. This triangle on the left here has to be congruent to the triangle on the right there. And that's the part that we're going to use to help solve this. So to find the whole angle in green, I'm going to find the angle in blue. We've got a right triangle. I want to find this angle, so I'm going to call it angle A. In order to find the measure of angle A, I'm going to use the hypotenuse and the side that's adjacent. So that means I'm going to select the cosine of angle A equals the opposite side, or I'm sorry, the adjacent side has a length of 3, the hypotenuse has a length of 6. So we can find A by running the inverse cosine of 3, 6. If you punch that into your calculator, it should give you 60 degrees if you're in degree mode. If you're not getting that, check your mode, you're probably in radians. So if angle A is 60 degrees, then we want to double it to get the entire angle with the central angle, which is 120 degrees. Okay, so that finishes up our problem on the CYU.